Hello my dear students, I hope your day is fine. Our objectives for today in chemistry are to identify the types of physical properties and to distinguish pure substance from mixture by their physical properties. A substance can be identified by its physical properties. So each substance has its own properties. These physical properties can be divided into two types: descriptive physical properties and measurable physical properties. Descriptive physical properties, everything talked about color, smell, or taste about the substance, they are called descriptive properties. However, on the other hand, everything included numbers such as the boiling temperature of the substance, melting point, its freezing point, its density, its mass, its volume, all of these are called measurable properties. So for a substance can be identified by its physical properties either by descriptive or by measurable. What is the difference between these types? Descriptive, such as the color, the taste, the smell, they depend on observing, they depend on our eyes, what we see, what we taste, what we hear, also we can say. And measurable properties depend on numbers. Whenever we see a number, so we say that it's a measurable properties and it's not a descriptive one. Let's read this example. A substance tastes sweety, has no smell, its color white. So here they are talking about the descriptive physical properties for the unknown substance. Why they are descriptive? Because they are telling us about the taste, about the color, about its smell. So because of that they are called descriptive. Has a boiling point 102.8200. These are measurable physical properties. Why they are called measurable? Because we are here talking about the boiling point and we are talking about numbers. So when we have a number, so we call it measurable and non-descriptive. So by using both descriptive and measurable physical properties, we can know that this unknown substance is called sugar. Sugar has a sweety taste, has no smell, its color white, it has a boiling point 102.8200. By these physical properties, we are allowed to identify this unknown substance, which is here sugar. Now please, I want from you to bring your books and read with me activity number 1, page 19 on your chemistry book. We have materials and procedure. What the meaning of materials? Materials means what they use from glassware, from the laboratory glassware, and by doing this experiment. And the procedure, what are the steps they did it while they are making this experiment. First, they start by preparing a salt water in a 200 milliliter graduated cylinder by dissolving 10 grams of sodium chloride in 50 milliliter distilled water. Sodium chloride, it's mean salt. So the chemical name for a salt, it is called sodium chloride. They are the same. Salt is sodium chloride and sodium chloride is the salt. So first they prepare a salty water in a graduated cylinder. Then they pour 50 milliliter distilled water into another 200 milliliter graduated cylinder. Till now they obtained two graduated cylinders. The first one contained salty water and the second one contained only water. Then after that they dip the hydrometer in each graduated cylinder and record the corresponding readings. What this means? First, in order to know what this means, we must know what is the meaning of a hydrometer. Hydrometer, it is a device used to measure density, which is a specific gravity also, for a liquid. So as you see in the picture, this is a hydrometer. It looks like a thermometer, but it's not a thermometer, it's a hydrometer. Usually it is used to measure the density of a liquid. They put it inside a graduated cylinder in order to read the number, the density of each liquid. First they put this hydrometer in the salty water. Second, they put it in the water alone. What we see after putting the hydrometer in each graduated cylinder: first, if we look at the figures 7a and 7b, we see that hydrometers gives 1.02 gram per milliliter for salty water, and it gives 1.0 gram per milliliter for distilled water. So the hydrometer gives different numbers, different densities for the different solutions. Then after that they add 25 milliliter distilled water into each graduated cylinder and record the new recordings. So what this means? This means that the first graduated cylinder, which contains salty water, they add water. In the second one, which contains only water, also they add water. Then after that they record again the density of each liquid by using the hydrometer. The hydrometer now gives new recordings. What are they? They give 0.9 gram per milliliter for the salty water and gives 1.0 gram per milliliter for distilled water. What we can conclude here? So look at the recordings and think what is the conclusion, or what changes happened here. After they add water to the both graduated cylinder, they pour 20 milliliter of the content of each graduated cylinder into a 250 milliliter beaker and vaporize to dryness. So what they made, they pour some salty water in another beaker from the graduated cylinder, and then they pour some water from the graduated cylinder into another beaker, and then they vaporize it till dryness. What happened here? Look at the pictures and know what happened. The results in the first beaker, after vaporizing water, nothing was found in the beaker. An empty beaker was seen. While in the second beaker, in the salty water, crystals, white crystals, were found at the bottom of the beaker. They are crystals of salt. Now, after we read the experiment, let's now solve the exercises, page 20. In the first exercise, they are telling us to compare the readings of hydrometer in each case. First, the density of distilled water was 1 gram per milliliter, which is less than the density of salty water, which is 1.02 gram per milliliter. After we add water, the second reading, the recordings change only for salty water, but it remains the same for the distilled water. After adding water, density of water, which is 1 gram per milliliter, become greater than the density of salty water, which is 0.9 gram per milliliter. Density of salty water change after adding the water from 1.02 till 0.9 gram per milliliter. The second question they are asking us, did the addition of water change the density? So what you think, did the addition of water change it? For the pure substance, as we see, no change was in the density, while for the mixture, salty water decrease in density was found. So the recordings of the hydrometer for the pure substance, which is distilled water, there is no change was found, while for the mixture, which is the salty water mixture, because it's made up of two substances, there is a decrease in density. The density, it changes. The third question they are asking us, after vaporization to dryness, in which beaker were crystals left? As we see in the beakers, we observe that crystals were left in the second beaker, which is the beaker of salty water. So to sum up, a pure substance which is made of one kind of material, as we took in the last video, has constant fixed physical constants or physical properties such as density, boiling point, melting point. Doesn't it change by adding water or by vaporization? So if we add water or if we vaporize, the readings, they will be the same. There is no change. Why? In a mixture such as the salty water, which is made up of more than one material, as also we took in the last video, has variable physical constant. So the density or the boiling point or the melting point or any of its properties can change by changing the its content. If we add water or if we vaporize, the recordings change. For example, if we add water to a mixture, all of the density decrease, and if we vaporize our mixture, the density increase, as in our case for today. Hydrometer is a device used to measure density of a liquid. Don't forget it. To see if you understand or not, let's apply or answer this application. We measure density using a hydrometer for beaker A after adding water to it. No change was found, while we observe a decrease in density in beaker B after adding water to it. They are asking us which of the beakers contain pure substance and justify. Beaker A contains a pure substance. Why? Because it has a constant density. They have a fixed physical properties, physical constant, because the density didn't change. Because of that, we know that beaker A is a pure substance, while beaker B contains a mixture. Since in beaker B there was a decrease in density. So by the end of this video, I hope you understand our lesson for today and the objectives are well done, and you understand that how to distinguish between a pure substance and a mixture by their physical properties. Wish you a nice day.